This Zoom session is being brought to you by the Fractal Octaves S. All right, today we do dividing polynomials, section 3.3, and real zeros of polynomials, section 3.4. In 3.3, we use a variant of long division. There's a long division algorithm for dividing an integer by an integer. We'll do a similar one to divide a polynomial by a polynomial. So for example, 156 over 13 is what? Well, right, 156 in here, right, the 13 outside the bracket. 13 goes into 15 once, so put a 1 there. 1 times 13 is 13. Subtract, left with a 26. 13 goes into 26 twice. Twice 13 is 26. Subtracting it, nothing. So therefore, 156 over 13 equals 12, like that. Now, here we go. Here's going to do a similar thing. 1x squared plus 5x plus 6 over 1x plus 3 is what? Now, obviously, you can see the 156, 156, 13, 13. It'll be very similar. So we write an x squared plus 5x plus 6 inside this bracket and an x plus 3 outside of it. Now, what we do is we look at ratios of leading terms. X squared over x, that's x. We put that x into the quotient here. X times x plus 3 is x squared plus 3x. Subtract, we're left with a remainder of 2x plus 6. Look at leading terms. 2x divided by x is 2. Put that in the quotient. 2 times x plus 3 is 2x plus 6. Whoops, subtract out and left with nothing. 3, 3, 1, 2x plus 6. I should adjust this in the canvas. We proceed. Or here, to divide t cubed plus 8t squared plus 13t plus 9 by t plus 6 is what? Well, okay. Put t cubed plus 8t squared plus 13t plus 9 in the bracket, t plus 6 outside. Take ratio of leading terms. T cubed over t is t squared. Put that in the quotient. T squared times t plus 6 is t cubed plus 6t squared. Subtract. We're left with 2t squared plus 3t plus 9. Now, 2t squared over t is 2t. Put that in the quotient. Times t plus 6 is 2t squared plus 12t. Subtract, we're left with t plus 9. T divided by t is 1. Put that in the quotient. Times t plus 6 is t plus 3. T plus 6. Subtract, and we're left with a remainder of 3. So the ratio, this over this, equals the quotient, t squared plus 2t plus 1, plus the remainder 3 over divisor, t plus 6. So if we have a denominator divided into the numerator, and after a bunch of subtractions, we have a quotient and a remainder, the numerator over denominator equals quotient plus remainder over denominator, like that. Now, there's a shortcut for doing for doing these divisions, especially when we're dividing by variable plus x, variable plus minus c. So this is something we'll be doing a lot. Polynomial divided by x minus c. Basically, it's a way of finding out what the polynomial equals at c. So if we do this, for example, we do this example, 3b squared minus 1b plus 13 divided by b minus 3. So here we have the numerator, here we have the denominator. Look at ratio of leading terms, 3b in the quotient. 3b times b minus 3 is b squared minus 9b. Subtract, we'll have minus 22b plus 13. Minus 22b over b is minus 22 into the quotient. And after the appropriate multiplication, subtract, we're left with minus 53 for a remainder. So the ratio equals the quotient plus remainder over denominator. 3b minus 22 plus negative 53 over b minus 3. Now, I'm going to do the whole thing again, only with a lot less scribbling, fewer variables and fewer rewrites of numbers and so on. Basically, bring it down to its very bare minimum. This 3b squared minus 31b plus 13 we write as this, 3 minus 31, 13. Now, for reasons that'll become clear in a bit, instead of a b minus 3, we put a plus 3 this time. To compensate for the minus turning into a plus, instead of subtracting at every level, we will add at every level. So what we do is bring down the 3, like this 3 here, times 3 is a 9, which we put here. Minus 31 plus 9 is minus 22. Minus 31 minus negative 9 is again minus 22. Minus 22 times 3 is negative 66. Well, here you go, plus 66. Here we subtract, here we add, negative 53 here and negative 53 here. So what we do is a kind of with this thing's called synthetic division. Dividing a polynomial, divide by b of x minus c. Put the polynomial's coefficients here, we put a plus c here, and then we go zigzag down and up and down and up and down. Every time we go down, we add. Here we're subtracting because we had a negative here. We have a positive, so we add here. Every time we go down, we add. And every time we go up, we multiply by this number, in this case, 3. So add times 3, add times 3, add. Okay. And okay, when we do that, here we have a 3 minus 22, that's 3b minus 22. And then a minus 53, that's negative 53 over b plus 3. Same as what we got here. So with a plus turned into a minus and an add, subtract into an add. But basically all the numbers come out the same, so that's what we do as a simplification. So for example, divide 4t cubed minus t minus 18 over t minus 2. Because it's the t minus 2, we put a plus 2 here. 4t cubed. There's no t squared, so we put a 0 there. Minus 1t, here it is, minus 18 here. Every time we go down, we add, and every time we go up into row, we multiply by this 2 here. Bring down to 2, down to 4, that's a 4. Times 2 is an 8. Plus 0 is an 8. Times 2 is a 16. Plus negative 1 is a 15. Plus times 2 is a 30. Plus negative 18 is a 12. So this ratio equals 4t squared plus 8t plus 15 plus 12 over t minus 2. Or let's try, well, here we have a quote, something divided by x plus 1. Well, this is all messed up, and this is x plus 1. We'll rewrite this as x cubed minus 4x squared plus x plus 6 over x plus 1, right, is x minus a negative 1. So in the synthetic division, we put 1, negative 4, 1, 6. 1, negative 4, 1, 6. And in the upper right, in this corner here, we put a negative 1. So down comes a 1 times negative 1 is a negative 1. Plus a negative 4 is a negative 5 times a negative 1 is a 5. Plus a 1 is a 6 times a negative 1 is a negative 6. Plus a 6 is a 0. Ooh. Remainder of 0. So the ratio equals just x squared minus 5x plus 6, no remainder. Now, if we have, now this remainder is important because if we have a ratio, p over x minus c is quotient plus remainder over x minus c, then when you multiply by x minus c, get p equals q times x minus c plus r. And in particular, if you put x equal to c, then p of c equals q of c times c minus c is 0. This term goes away entirely. All left is remainder r. P of c is r. The remainder is p evaluated at c. So for example, this 0 is this polynomial evaluated at negative 1. So for example, you have 2x cubed plus x plus 0. What is p at 3? Okay, 2x cubed, we have to put in a 0 where there's no x squared term, plus 1x plus 2. To evaluate at 3, we put the 3 here. Every time we go down, we add. Every time we go up and to the right, we multiply by this 3. Brings down to 2. 2 times 3 is 6, plus 0 is 6, times 3 is 18, plus 1 is 19, times 3 is 57, times 2 is 59. So p at 3 is 59. Or here's x to the 4th minus 2x squared plus x squared minus 3x plus 2. What is p at negative 2? All right, fine. 1x to the 4th minus 2x cubed plus 1x squared minus 3x plus 2, evaluated at negative 2. Every time we go down, we add. Every time we go up and to the right, we multiply by negative 2. Down comes a 1 times a negative 2 is a negative 2. Plus a negative 2 is a negative 4 times a negative 2 is an 8. Plus a 1 is a 9 times the negative 2 is an 18. Just a second. Where was I? Plus a negative 3 is a negative 21 times a negative 2 is a 42. Plus a 2 is a 42. So p at negative 2 is 44. All right, here, for example, 5x squared minus 27x plus 10 over x minus 5 is what? I put x minus 5 outside the long division and put 5x squared minus 27x plus 10 inside of it. 5x squared over x is 5x, put that in the quotient, times x minus 5 is 5x squared minus 25x. Subtract, we're left with a negative 2x plus 10. Negative 2x over x is a negative 2 in the quotient. Negative 2 times x minus 5 is 2x plus 10. Subtracting, get 0 remainder. And so this ratio will just be the quotient 5x minus 2 with no remainder. Here we have 3b squared minus 31b plus 13 over b minus 3. What's that? All right, b minus 3 outside. 3b cubed, 0b squared, you have to put in those placeholders, minus 31b plus 13. Here we go. Leading terms, 3b cubed over b is 3b squared. Put that in the quotient. 3b squared times b minus 3 is 3b cubed minus 9b squared. Subtract, 0 minus negative 9 is a plus 9. 9b squared minus 31b plus 13. Okay, leading terms, 9b squared over b is 9b. Put that in the quotient. 9b times b minus 3 is 9b squared minus 27b. Subtract, this cancels. Negative 31 minus negative 27 gives a negative 4, negative 4b plus 13. Leading terms, 4b, negative 4b over b, ratio of negative 4. Put that in the quotient. Negative 4 times b minus 3 is negative 4b plus 12. Subtract, has a remainder of 1. So the ratio is 3b squared plus 9b minus 4 plus 1 over b minus 3. Quotient plus remainder over denominator. Now here they have thing over x plus 1, and okay, this is deliberately scrambled up. Let's write it in reducing powers. X cubed minus 4x squared plus x plus 6 over x plus 1. All right, x cubed minus 4x plus x plus 6. Here's the x plus 1 outside. Leading terms, x cubed over x is x squared. Put that in the quotient. X squared times x plus 1 is x cubed plus x squared. Subtract, minus 5x squared plus x plus 6 remains. Leading to ratio of leading terms, minus 5x squared over x is minus 5x. Put that in the quotient. Minus 5x times x plus 1 is minus 5x squared minus 5x. Subtract, x minus negative 5x is x plus 5x is 6x. So 6x plus 6. Look at leading terms, 6x over x is 6. Put that in the quotient. 6 times x plus 1 is 6x plus 6. Subtract, no remainder. So the ratio will just be the quotient. The ratio will be x squared minus 5x plus 6, right here. All right. You have another one. 8 minus 3x plus 7x squared plus 2x cubed over x plus 5 is what? Well, okay. First, we arrange this in descending powers of x. 2x squared plus 7x, 2x cubed plus 7x squared minus 3x plus 8 over x plus 5. So put that in there and that in there. And you go through the same process as before. We'll wind up with a remainder of negative 52 and a quotient of 2x squared minus 3x plus 12. So the ratio equals a quotient plus the remainder over the denominator. 2x squared minus 3x plus 12 plus negative 52 over x plus 5. Now here we'll be evaluating the polynomial. X cubed minus 4x squared plus x minus 2. What is p at 2? Well, all right. 1x cubed minus 4x squared plus 1x minus 2. Put a 2 out here. Every time we go down, we add, and every time we go up and to the right, we multiply by 2. Bring down the 1 times the 2 is a 2, plus the negative 4 is a negative 2, times the 2 is a negative 4, plus the 1 is a negative 3, times the 2 is a negative 6, plus the negative 2 is a negative 8. So p at 2 equals negative 8. Oh, by the way, this method of calculating by finding p of x by using synthetic division is actually more efficient than just plugging it in. because if I plugged in 2 here and here and here, I'd have, well, let's see, 2 multiplications there. Another pair of another 2 multiplications here. That's 4 in all. Also 1, 2, 3 additions. Well, this just did 1, 2, 3 multiplications and 3 additions, so it's faster. All right.